Today we're going to talk about a recent study that used 3D modeling to reconstruct the body of an ancient extinct shark known as Megalodon. We'll try to understand how this reconstruction actually works, and we'll also talk about the main conclusions from the study, including inferences about Megalodon's role as, quote, a transoceanic superpredator. So the paper, which is linked below, starts off by talking about what a Megalodon was. And as I mentioned before, it's basically a giant extinct shark. Most of the remaining fossils are the teeth. It says on the basis of the age, morphology, and worldwide distribution of these teeth, it's been proposed that this species was a cosmopolitan predator. So in this case, cosmopolitan refers to its propensity to basically travel all over the globe. So it's kind of like a globe-trotting serial killer. And it lived from the Miocene to the Pliocene, so 23 to 2.6 million years ago, or MA. As I said before, the Megalodon was giant, so it says the body length of the iconic Megalodon has been inferred on the basis of tooth measurements and comparisons with the extant great white shark. So this is actually where I struggle a little bit with this type of science, because they're basically saying, well, we have a few vertebrae and we have a bunch of teeth, and if we imagine that it looks like a great white shark, then it would be like a huge great white shark, and then you start making all these inferences and extrapolations about what the Megalodon was like. But at the end of the day, you're still drawing a picture of a giant, body when all you have is the teeth and a few vertebral columns, or vertebrae rather. So I actually found this question answered on Quora by a marine biologist. And the question is, why do we depict the Megalodon as an oversized great white shark if all we have are its teeth? How do we know if the Megalodon had unique features? Or maybe, how do we know that the Megalodon didn't have unique features, right? Like maybe it had tentacles or something like that, or I don't know, maybe it had two mouths. So Richard Pierce, who's a PhD in marine biology and plankton organisms, University of Rhode Island, said, it is called the principle of parsimony, or Occam's razor. In science, there may be several explanations for an observation. Unless there is evidence to the contrary, scientists take the least complex answer to be the correct one. Science is always subject to revision when more evidence is found. In the example of Megalodon, all we have are teeth. Well, we have some vertebrae too. We do have a living shark that has very similar teeth, although much smaller. The resemblance of teeth is so similar that when we look at the tooth shape of the great white sharks based on the position in the jaw, we find the same variation in tooth shape in Megalodon. So not only is for humans we have different types of teeth, and I guess not surprisingly, great white sharks are the same. And so they're saying for all these Megalodon fossilized teeth, not only do they have maybe like the same characteristics as a great white shark, but they even have the same distribution. So that would be like us having, finding some canines and some molars. And so he says the simplest explanation is that Megalodon is a scaled up version of the great white shark. Megalodon could have some unique features that we don't know about, but without evidence, we would just be making wild speculation. So it's Occam's razor, or the principle of parsimony, which I've never heard it called that. But I am familiar with Occam's razor, and I've used it frequently in my own work. Now, so I'm really grateful to Richard Pierce for that, but then he goes on and he says the principle of parsimony is why most scientists don't believe in pseudoscience, cryptozoology, and alien abductions. I cannot say with certainty that Bigfoot does not exist. All the evidence that has been brought to light is tenuous and possibly fabricated. And I love the way he breaks this down. He says, the two hypotheses are that there is a giant anthropoid creature that has so far never actually been found in the USA, or there is not any such creature. All right, so which do you think that Richard Pierce believes in Bigfoot? That's what I want to know. Okay, it sounds like not. So I think that's pretty interesting. It's a good point, and it is a pretty good answer, I think, to the Megalodon issue. Basically, if we're seeing what look like giant great white shark teeth, then the simplest explanation is to assume it's a giant great white shark. Okay, so back to the article. So we're looking at figure 1, and this is basically a walk down of their modeling procedure. So they're taking the teeth, they're using 3D, they're taking the teeth and the vertebral columns, and they're basically putting together the mouth and then making inferences about the length of this particular specimen. They were working primarily from a vertebrae column from the Belgium specimen. So from the 3D modeling, they were able to make some predictions. One of them is the length, so the total length in meters would be 15.9 meters, which for those of us who are more used to imperial units, so that would be over 50 feet long, which is just absolutely disgusting to consider. In addition, the body mass would be well over 60,000 kilograms. And they also, I believe from known shark species, there's sort of a ratio between the length of the shark and the cruising speed that's typical. So they were able to estimate what the cruising speed would be, 1.4 meters per second. And they were also able to make inferences about the stomach volume and then the gape angles. So this is having to do, I believe, with like the mouth of the shark. The stomach volume is a certain size and the mouth is a certain size. I believe that they're trying to make inferences about the type of prey that the Megalodon would feed on. Here we have in figure 2, we have an estimate as to the cruising speed of the Megalodon. I said it was 1.4 meters per second, but that would compare to the great white shark, for instance, which is somewhere a little bit less than 1 meter per second. So it would be the fastest shark on the high seas. As I said before, they made estimates as to what sorts of food the Megalodon would be able to eat based on the stomach volume and the gape size, and they talked about basically be able to eat a whole lot of different species, including orcas. So they mentioned, specific prey could have been eaten in just 3 bites. Some of them would be 5 bites. This one said a larger prey of 7 to 8 meters would then have had to be severed into 5 or more chunks. They estimated the shark's energetic demands using the previous established relationship between body mass and daily energy requirement based on great white shark individuals, and they found that the Megalodon model required 98,000 kilocalories per day, which is 20 times higher than the adult great white shark, which apparently eats about 5,000 calories per day for a 900 kilogram individual. And that's interesting. That's actually less food than I would have anticipated. For example, when I think about trying to contextualize amounts of calories, I'm a fan of strongman, so it's interesting to note that this guy, Hafthor Bjornsson, is actually eating twice as much food as a great white shark every day. What I think is really interesting when they're talking about the aspect of what the dietary or the caloric budget of the Megalodon would be, they can break that down basically into kilograms of blubber or kilograms of liver or kilograms of flesh that the Megalodon would need to eat on average per day to satisfy their caloric needs. Where that becomes very interesting to me is that when you consider the fact that it has such a huge mouth and such a huge stomach, and it can eat these, like an entire dolphin. They study that, in contrast, Megalodon could have eaten only every 145 days, or 5 months, if it fed exclusively on the largest prey, those which were greater than 12 meters. They go on to say that maybe that's a little bit unlikely every 5 months, but it might be more common for it to go at least, 2 months without eating. And this really does emphasize the idea, when you combine this with the fact that it probably had a very high cruising speed, it could swim very quickly, that the Megalodon could basically go from one part of the ocean to a part of the ocean maybe thousands of miles away in between meals. So when we talked about it being described as a transoceanic superpredator, that's really what we're talking about. The ability to cross vast stretches of empty ocean without any food and just being 100% fine with that. It's kind of interesting to think about that sort of in context of a human dietary need. So, if they're going to go every 145 days without eating, or let's just say it's like conservatively it's 100 days without eating, then what would that be for us? Like, how many Big Macs would it take for us to... Well, how many Big Macs would we have to eat in one sitting to then not do anything, not eat anything, and just go on like a 100-day journey? Okay, so a McDonald's Big Mac has 563 calories, and if we're saying like an adult human typically is supposed to eat 2,000 calories supposedly, so 2,000 times 100 is 200,000. So, so this would be like us eating 355 Big Macs. And then walking for 100 days. That's kind of what the Megalodon is doing, most likely based on the reconstructions and the inferences about the ecological habits based on the size of the mouth and the stomach size and the inferred cruising speed. That's kind of what it means to be a transoceanic superpredator, put in human terms. You're going to sit down and eat 355 Big Macs and then just be like good for 100 days. I think we would just be dead. But it's interesting to think about that in human terms. Well, thanks so much for watching. If you enjoyed the video, please go ahead and hit like, and I hope you'll join me again in the future soon. Bye.